From previous session, we learned about pointers and structures, and also we learned like how to declare structures, how to use it in the programming. As part of this session, we learned about Go concurrency, Go routines, Go channels, and etc. Let's discuss about Golang concurrency, Go routines, and channels as part of this session. So concurrency is a key feature of Go, and it is designed to make it easy for developers to write efficient and scalable applications that can take advantage of multiple CPU cores. Go routines are lightweight threads of execution in Go. They are created using the keyword Go and then run the same address space as the main function. Go routines are used to run multiple functions concurrently, and they can be used to write concurrent programs that are scalable and efficient. Channels are type of communication mechanism in Go that allow Go routines to communicate with each other. They are used to send and receive values between Go routines, and they provide a way to synchronize Go routines and control access to shared resources. Select statement. The select statement is a way to multiplex communication on multiple channels in Go. It allows Go routines to wait on multiple channels and execute the first one that is ready. The select statement is used to implement complex communication patterns between Go routines. Wait groups. Wait groups are used to wait for multiple Go routines to finish. They provide a way to synchronize Go routines and ensure that all Go routines have been completed before the program exits. Mutexes. Mutexes are used or a type of synchronization mechanism in Go that are used to control access to shared resources. They provide a way to ensure that only one Go routine can access a resource at a time, and they are used to avoid race conditions and other concurrency related issues. By using Go routines, channels, and select statement, wait groups, and mutexes, developers can write concurrent programs that are scalable, efficient, and safe. Go provides a rich set of concurrency related features that make it easy for developers to write concurrent programs, and it provides a simple and efficient way to take advantage of multiple CPU cores. So, the importance of concurrency. Efficiency. Concurrent programs can make the most of available resources, such as multiple processors or cores in a computer system, by allowing a multiple tasks to run simultaneously. This can significantly improve the performance and efficiency of software applications, especially for tasks that are resource intensive or time consuming. Scalability. Concurrent programs can scale to handle large workloads, as additional resources can be added to the system to support more concurrent tasks. This makes concurrent programs well suited for cloud based applications and their distributed systems that require scalable and responsive performance. Responsiveness. Concurrent programs can be designed to be more responsive to user input and other extensive external events, as they can continue to run in background while waiting for input or events to occur. This can make software applications feel more interactive and seamless to users. Modularity. Concurrent programs can be designed in a modular way with different tasks and functions running independently in their own Go routines. This can make it easier to write, test, and maintain software applications, as changes to one part of the program are less likely to affect other parts. Fault tolerance. Concurrence programs can be designed to be more resilient or to failure and errors, as errors in one part of the program are less likely to cause the entire program to fail. By using channels and other concurrency constructs, it's possible to design programs that can recover from errors and continue running with minimal disruption. Overall, the importance of concurrency in modern software development cannot be overstated, as it enables developers to create software applications that are more efficient, scalable, responsive, modular, and fault tolerant than traditional single-threaded programs. What are Go routines? In Go, Go routines are lightweight threads of execution that can be created and managed by Go runtime. Go routines are similar to threads in other programming languages, but they have lower overhead and are more efficient, making it easy to create thousands of them in a single program. To create a Go routine in a Go, a developer can use the Go keyword
followed by a function or a method call. When the function or method is executed, it runs in a separate Go routine, allowing other Go routines in the program to run concurrently. Go is the keyword, and you can write the function name, any function name, whatever you want to make it a Go routine basically. So for example, in the code, like in the function hello, it just prints the hello Go routine. In the main function go hello, this is what actually we are making a concurrent call to the hello function. So the hello function like prints message in the to the console, and then main function prints the another message. We'll see that in the hands-on coding time. So the program output will be like a main function will be printed first, but we are calling go routine hello function first, and then actually the hello go routine will be printed. Note that the hello program message is printed after the main function message, even though the hello function is called first. This is because the hello function is running a separate go routine which runs concurrently with the main go routine. So go routines are managed by the Go runtime, which schedules their execution on available processors or cores in the computer system. This allows multiple Go routines to run simultaneously, which can improve the performance and efficiency. Channels. In Go, channels are powerful concurrency construct that allows Go routines to communicate and synchronize with each other. Channels can be used to pass data between Go routines and also be used to implement synchronization mechanisms such as locks, semaphores, and barriers. A channel is created using the make function, and its type specified the type of the data that can be passed through it. Channel name equal to make channel type. Type will be any data type. For example, the following code creates the channel that is used to pass integer between the Go routines. Here actually ch is the channel name, and make chan is a keyword, and make is a function, and it takes the integer type. So to send a value through a channel, a Go routine can use that operator, left arrow operator with the channel variable on the left side. For example, ch and arrow left arrow operator, and you can write the any integer value, so it will be written into the channel. Actually this sends the value 42 through the channel ch. To receive the value from the channel, a go routine can be used the same operator like left arrow operator, but with the channel variable on the right side actually. For example, x equal to left arrow operator with channel. Now it is reading from the channel and it is assigned to value x, value from ch, and assigned to the variable x. The channels can be used to synchronize the execution of multiple coroutines. For example, consider the following code. So in this code, the worker function is a separate go routine, right? That receives value from the channel ch and prints to the console. The main function creates a new go routine by calling the worker with the using go keyword, right here, and then it sends the value 42 to the channel. Note that we will see the output once we have gone to the hands-on coding. So basically what happens, receive 42 will be printed after the send 42 message, even though the cs42 line is executed first. This is because the worker go routine is blocked on the channel line ch line here, this one, waiting for the value to be sent through the channel. When the main go routine sends the 42, the worker go routines is unblocked and prints the message to the console. Let us see the hands-on coding now. So let's go to go routines. So here we wrote just one simple function, and we are calling from the go followed by the function name. So basically let us see, like if you, I didn't discuss about this line in the programming in our presentation. Let us discuss now about this. What is that? So now what we will do is we'll see go run that this method, this command you are aware already. Now we observe that we are just printing main function. Why? Because go routine, like the separate go routine is created, but main function got exited before executing the main, executing the go routine hello method. So for that actually I used this wait method, sleep actually here for 1 millisecond, so that it will get the chance to execute allo go routine basically. Okay, now if you see, it will print both. So you can you observe closely now, if you see that the main function is printed first, even though we are calling hello method first using go routines. This is the separate go routine, that separate it will be using, it will be running actually in the different context. That allocation, like the execution part can be decided by the available resources during execution. So that's why it is executed later after main function is going to execute, right? So that is how it is go routines. And let us talk about channels now. So if you observe this, so here if you see, right, I just wrote one worker here, and I am passing the channel to this particular worker method, and I am trying to read the channel value from the X, and I'm just printing whatever the value I'm receiving here. Similarly, in the main function, I'm creating a channel of type integer. I'm calling go routine and I'm passing channel to that. After that, I'm filling 42 with the channel using this operator, and then I'm printing this, and I'm waiting for this. You know why I'm waiting here? Because of go routines to execute, to get the opportunity to execute go routine like worker in this case. So you see that, right, when even though we receive actually started printing first, because when we wrote this value to the channel, and this worker will be waiting for the to read the value from the channel, and then only it will unblock to enter here. So after that only this print will be printed, and then 42, and then only this value will be printed.